Question 1. A company operates a global SaaS application and needs to ensure low latency and high availability for users worldwide, even during regional outages. Which core feature of AWS Global Accelerator helps achieve this by providing fixed entry points? Option A. HTTP/HTTPS caching at edge locations. Option B. Dynamic DNS-based routing with health checks. Option C. 2 static Anycast IP addresses. Option D. Direct Connect private network links. The correct answer is 2 static Anycast IP addresses. Here's the explanation. AWS Global Accelerator provides 2 static Anycast IP addresses that act as fixed entry points for your applications. These IPs are advertised from multiple AWS edge locations simultaneously, directing user traffic to the nearest healthy edge location. Question 2. How does AWS Global Accelerator primarily improve the performance of applications for global users? Option A. By caching static content at AWS edge locations. Option B. By routing user traffic over the highly optimized AWS Global Backbone Network after the initial hop to an edge location. Option C. By performing client-side DNS resolution to the closest application endpoint. Option D. By providing dedicated private network connections from users to AWS regions. The correct answer is by routing user traffic over the highly optimized AWS Global Backbone Network after the initial hop to an edge location. Here's the explanation. Global Accelerator directs user traffic to the nearest AWS edge location, and from there, the traffic traverses the highly optimized and congestion-free AWS Global Backbone Network to the closest healthy application endpoint, bypassing the unpredictable public internet. Question 3. Which statement correctly identifies a key difference between AWS Global Accelerator and Amazon CloudFront? Option A. Global Accelerator operates at Layer 7 HTTP/HTTPS for content delivery, while CloudFront operates at Layer 4 TCP/UDP for network optimization. Option B. Global Accelerator caches static and dynamic content, while CloudFront only routes live traffic. Option C. Global Accelerator optimizes the network path for dynamic, non-cache traffic at Layer 4 TCP/UDP, while CloudFront caches content at Layer 7 HTTP/HTTPS. Option D. Global Accelerator uses DNS-based routing, while CloudFront uses static Anycast IP addresses. The correct answer is Global Accelerator optimizes the network path for dynamic non-cache traffic at Layer 4 TCP/UDP, while CloudFront caches content at Layer 7 HTTP/HTTPS. Here's the explanation. Global Accelerator operates at Layer 4 TCP/UDP and optimizes the network path for dynamic application traffic by leveraging the AWS backbone. CloudFront is a content delivery network, CDN, that operates at Layer 7 HTTP/HTTPS and focuses on caching static and dynamic content at edge locations. Question 4. What is the primary purpose of hybrid networking in cloud architecture? Option A. To completely replace on-premises infrastructure with public cloud resources. Option B. To create a seamless, unified network fabric spanning on-premises data centers and public cloud environments. Option C. To isolate all on-premises resources from any public cloud connectivity. Option D. To manage network traffic exclusively within a single public cloud provider. The correct answer is, quote, to create a seamless, unified network fabric spanning on-premises data centers and public cloud environments. Here's the explanation. As stated in the overview, hybrid networking represents the strategic integration of an organization's on-premises data center infrastructure with public cloud environments, creating a seamless, Unified Network Fabric. Question 5. Which two connectivity options are commonly used to establish a secure and reliable link between an on-premises data center and a public cloud virtual network in a hybrid networking setup? Option A. Public Wi-Fi and Bluetooth. Option B. IPsec VPN tunnels and dedicated private connections, e.g., Direct Connect, ExpressRoute. Option C. Dial-up connections and satellite internet. Option D. Cellular data and Ethernet crossover cables. The correct answer is IPsec VPN tunnels and dedicated private connections, e.g., Direct Connect, ExpressRoute. Question 6. When designing the IP address scheme for a hybrid network, what is a critical consideration to prevent routing conflicts and enable seamless communication? Option A. Using only public IP addresses on premises. Option B. Ensuring overlapping IP address ranges between on-premises and cloud networks. Option C. Using dynamic IP addressing exclusively. Option D. Ensuring non-overlapping IP address ranges between on-premises and cloud networks. The correct answer is ensuring non-overlapping IP address ranges between on-premises and cloud networks. Here's the explanation. The exam tips and how it works sections emphasize that carefully planned, non-overlapping IP address spaces, CIDR blocks, between on-premises and cloud networks are crucial to prevent routing ambiguities and allow seamless communication. Question 7. Which of the following statements accurately describes a fundamental difference between IPv4 and IPv6 addresses? Option A. IPv4 uses 128-bit addresses in hexadecimal notation, while IPv6 uses 32-bit addresses in dotted decimal notation. Option B. IPv4 addresses are typically represented in dotted decimal notation and are 32-bit, whereas IPv6 addresses are 128-bit and represented in hexadecimal notation. Option C. IPv4 inherently supports IPsec, making it more secure, while IPv6 requires IPsec as an add-on. Option D. IPv4 provides a significantly larger address space compared to IPv6, making NAT unnecessary. The correct answer is IPv4 addresses are typically represented in dotted decimal notation and are 32-bit, whereas IPv6 addresses are 128-bit and represented in hexadecimal notation. Here's the explanation. IPv4 uses 32-bit addresses typically represented in dotted decimal notation, e.g. 192.168.1.1. IPv6 uses 128-bit addresses represented in hexadecimal notation, e.g. 2001DB81. This is a core distinguishing factor. Question 8. An AWS architect is designing a solution where EC2 instances and a private subnet need to initiate outbound, only IPv6 connections to the Internet without being directly reachable from the Internet. Which AWS networking component should be utilized for this purpose? Option A. NAT Gateway. Option B. Internet Gateway, IGW. Option C. Egress-only Internet Gateway, EIGW. Option D. Virtual Private Gateway, VPG. The correct answer is Egress-only Internet Gateway, EIGW. Here's the explanation. The Egress-only Internet Gateway, EIGW, is specifically designed for IPv6 traffic from private subnets to the Internet, allowing outbound connections while preventing inbound ones. NAT Gateway is for IPv4, and IGW handles both IPv4 and IPv6 for public subnets. Question 9. When enabling IPv6 for a new Amazon VPC in AWS, which CIDR block sizes are typically assigned to the VPC and its subnets, respectively? Option A. A64 CIDR block for the VPC and 128 CIDR blocks for subnets. Option B, A16 CIDR block for the VPC and 24 CIDR blocks for subnets. Option C, A/56 CIDR block for the VPC and 64 CIDR blocks for subnets. Option D, A48 CIDR block for the VPC and 56 CIDR blocks for subnets. The correct answer is A56 CIDR block for the VPC and 64 CIDR blocks for subnets. Here's the explanation. AWS automatically assigns A56 IPv6 CIDR block to a VPC. Each subnet within an IPv6-enabled VPC is then assigned a 64 IPv6 CIDR block, which is the standard for IPv6 subnets. Thanks for watching. Please subscribe to my channel.